Section 10.1, Solving Systems Equations by Substitution and Elimination. In this chapter, we're going to be looking at linear equations, and recall that linear equations are equations with a highest degree of 1 for each variable. And graphically, they are a straight line. We're going to be looking at systems of linear equations. So when we'll start with two equations with x and y. When we have two linear equations like this, there's three possible outcomes of the relationship. We can have no solution, and this is what happens when we have two parallel lines. This is considered to be an inconsistent solution. And algebraically, what we'll see is a contradiction. For example, we might get 2 equals 6. So we call it inconsistent. It will appear as a contradiction algebraically, and graphically we'll get parallel lines. If we have one solution, it is called consistent. It means we can find a value for each variable, and we'll only find one. And what happens is we'll get intersecting lines, where the point of intersection is our solution. So here we have intersecting lines. Lastly, we can have the case of infinitely many solutions. This is also considered consistent, since we do have a solution. However, it is dependent. It's because the solutions depend on what the other variables take as values. What we will find algebraically is we'll get a true statement, such as 0 equals 0. Graphically, this will appear as concurrent lines. So two lines that lie one on top of another. These are three options: no solution, one solution, or infinitely many solutions. To solve for these solutions, we have two methods. We can either use substitution or elimination. We'll start with substitution. In the substitution method, we can break this down into 3 steps. Our first step is to pick one equation and solve for one variable. We then substitute that value into the second equation and solve for the other variable. Finally, we'll use back substitution into either equation and solve for first variable. This is probably easier when looked at with an example, so we're going to check out what that looks like. Note that when you move on past just x and y, you might have to modify or repeat these steps as necessary for those more than 2 variable situations. But let's look at an example.